My name is Duncan Winn. I've worked with Cloud Foundry since around 2012, first with VMware and currently with Pivotal. I work with companies helping them to install and configure Cloud Foundry. And throughout these engagements, I've come across a problem. There's a well-known business problem that we're all trying to solve. And that's the challenge of delivering software with velocity. And this is where Cloud Foundry can really help. However, there's also an underlying challenge, an underlying problem that gets in the way of delivering software quickly. And that's the challenge of buzzwords. So what do I mean by buzzwords? Well, we in the Cloud Foundry community are typically very comfortable with the terminology surrounding Cloud Foundry. And in fairness, these terms I'm going to refer to are not strictly Cloud Foundry buzzwords. They just exist within the space that Cloud Foundry operates. For example, we're very comfortable with the notion of consuming services and developing software against an appropriate level of abstraction. Establishing DevOps teams who adopt extreme programming to become agile, and use release engineering principles to build out automated CI/CD pipelines so they can deliver cloud-native 12-factor apps implemented as microservices, running in containers on a platform. This is what we do, and this space is vast. There's a huge amount to comprehend here. And when we talk about the stuff, people at first, they seem to get it, and they often respond with, we need to do all this stuff, and we need a platform like Cloud Foundry so we can deliver software quickly. But over time, what emerges is this phrase, the understanding of terms like Agile and DevOps, and not just what they mean, but the comprehension of the value they provide can sometimes be lost. Now, this is a serious problem, because we found that in general, by installing Cloud Foundry, you've already exceeded companies' expectations. They can move faster and do significantly more with a platform like Cloud Foundry than they could without a platform. The danger here, however, is that it's possible to think that deploying Cloud Foundry is all you need. However, without taking into account these wider concerns, these IT trends surrounding Cloud Foundry, you still may not be able to deliver software with the velocity you require. So this has taken me on a journey, and I've written a book on Cloud Foundry, and as part of that journey, I reviewed the IT trends surrounding Cloud Foundry, these trends listed here. And these are typically trends associated with delivering software with velocity. And at the back of my mind, with every buzzword I used, was what does this term really mean, and what's the value here to Cloud Foundry? So my hope is that within the Cloud Foundry community, we can start to agree on a shared terminology, not just the literal definition of a term, but the value of what the term is trying to achieve. And more importantly, what needs to change within your organization so you can deliver software at speed. So I've picked these 7 areas to start with, and with each area, I'm going to explain the principles underpinning the term, the challenges and misconceptions with the term, and how that term relates to Cloud Foundry. So let's begin with a really easy one, cloud computing. I'm sure everyone on this call is aware of what cloud computing is. This should be a really easy thing to explain because it's been around for a long time. So just to recap, the attributes associated with cloud computing include elasticity, the ability to dynamically handle growth by scaling up and back down again. On demand, the ability for me to choose when and how I want to consume a required service. And also self-service, the ability for me to directly provision a service, as opposed to raising a time-consuming ticket. So what are the misconceptions with cloud computing? I'm sure you've all seen a diagram like this. Cloud computing has been divided into as-a-service layers. However, this view is a logical representation, and it has 2 fundamental problems that cause confusion. It's too simplistic, and it's inaccurate because it shows clean boundaries between each layer. When you consider the hardware layer, assuming you can obtain those cloud computing attributes of elasticity, on-demand, and self-service, There's no reason why you can't leverage bare metal for your platform. The infrastructure where you run Cloud Foundry should largely be irrelevant. In addition, the layer above Cloud Foundry is not limited to SaaS-based applications. You can pretty much run anything on a platform like Cloud Foundry, be it Internet of Things applications, IoT applications, batch, computational, streaming jobs, back office applications. The list should be limitless. Finally, for mature enterprises, you're still likely to have some legacy applications, maybe running in VMs, maybe third-party packaged apps, or maybe even applications running on physical servers. Either way, this is a much more realistic stack. In addition, the stack does not always have clean boundaries, these clean lines between each layer. These lines are getting more and more blurred. For example, most people think of AWS as an IaaS layer, but when you consider the ever-expanding suite of services they offer, they start to very much bleed into the platform capabilities. So how does Cloud Foundry deal with this? It does so in two ways. It uses contracts and opinions. So starting with this cloud provider interface, this CPI layer, this allows a defined boundary between the infrastructure and the platform. This means that using Cloud Foundry, you're no longer locked into or bound to a specific infrastructure. You can install Cloud Foundry in many different environments, and by and large, you can expect the same experience. The platform itself is opinionated. Cloud Foundry is regarded as a structured platform providing built-in capabilities. It's opinionated on how things should run. Therefore, these platform opinions form a contract with the applications that run on it. This is where terms like 12-factor apps are often mentioned. So this is Cloud Foundry's view of cloud computing. It doesn't really care where you run Cloud Foundry, but it absolutely cares about how you run your apps on it. So moving on to another hot topic, containers. In recent years, there's been a rapid growth in container-based technologies. Containers give you a way of leveraging an isolated slice of a VM or machine in a secure way. And they achieve this through leveraging various OS features to control resources and isolate and secure processes. Both the technology around VMs and the container space are really rapidly evolving, and in some ways these two spaces have been merging together. But the reason why containers are so popular is that historically at least they've offered three distinct advantages over traditional VMs. And that's speed and efficiency, because they're super quick to create, greater resource consolidation, especially if you're overcommitting your resources, and application portability, because you can package up all of your app dependencies into a binary image. Containers are best thought of as having two core elements. The first is the file system or container image. This is the thing you actually run, be it a pre-built Docker image or a Cloud Foundry built droplet plus a stack. This packaged executable encapsulates your application and dependencies and can be run repeatedly in different environments. The second element is the container management component, or the container backend. Now, there are various pieces that comprise this backend, and the technology and terminology tends to be implementation specific. But no matter what technology you use, the end result should be the same. Ultimately, the container backend is the bit that builds and runs your isolated processes. Now, this term, isolated processes, brings us to our first misconception around containers. At least in the Linux world, there's no such thing as a literal container. Containers are a logical description. They're not literal entities. What you get is a process with some walls, some resource limits, some namespace isolation. Containers are just the bringing together of various kernel features. How you orchestrate those features is by and large an implementation detail. The concern over the implementation detail brings us to a more fundamental misconception with containers, and that's that implementation detail matters. The reality is it does not matter. So what do I mean by that? Well, consider the file system. There are absolutely differences. There's pros and cons to the approach of droplets, Cloud Foundry droplets versus Docker images. However, providing you build your application or container in a sensible cloud-native way that adhere to those platform opinions I described earlier, you're free to choose. In Cloud Foundry's view, it doesn't matter. Cloud Foundry supports both. In the same way, the back-end implementation, providing it does what it says, it really shouldn't matter. The interesting thing for me is about Cloud Foundry's level of abstraction. Cloud Foundry is about your applications and tasks that run on Cloud Foundry, not the containers. Containers, like middleware, are just another implementation detail. Developers shouldn't need to be concerned about things like the file system or process isolation. The final misconception is that all you need to do to deliver software quickly is use containers. Containers alone are not enough. You still need resilience, user management, aggregated streaming of logs and metrics, and all the many other benefits that a platform provides. So what do containers look like in Cloud Foundry? Well, as I mentioned, the file system, the thing you actually run, you can either push a Docker image or you can CF push your application artifact and let Cloud Foundry build you a droplet. For the management side, the thing that isolates and runs your process, Cloud Foundry is standardizing on using runc, the same backend technology that Docker and Rocket standardize on. And whilst I stand by my statement that providing it's done right, the backend implementation shouldn't matter, the fact that we're all adopting an industry standard is a really positive thing. It means we're collaborating for the good of the wider community and not expending effort reinventing the wheel, so that's a really positive thing. Moving on to Agile. Agile should be another well-understood topic. It's been around for over 20 years and it's been popular for at least the last 10. Most companies I work with would say they employ Agile methodology. They typically have things like inceptions, stand-ups, iterations, pointing, retros, etc. And some of the adventurers have even adopted things like pairing, test-driven development, domain-driven design. However, often the most fundamental piece of Agile is missing, and that's the frequent delivery of features into the hands of end users. This is vital because that closed feedback loop, without that closed feedback loop, it's harder to align your products to user expectations. So how does Agile and Cloud Foundry help you? Cloud Foundry helps you move from Agile development, where you run really quickly in development and then gag when it comes to production, to an Agile deployment model where you have an environment, a platform that you can repeatedly deploy to during your iterative development. So moving on to DevOps. Because DevOps is a culture, not a methodology, it means different things to different people. My colleague came up with this great definition. DevOps is a parallel solution for a perpendicular problem. So what does that mean? Well, most established businesses are structured around silos of speciality, such as networking or security. And whilst this looks really neat and orderly on paper, you get these perpendicular firewalls between different teams. And these walls between teams leads to these crazy flows of interaction, often resulting in raising tickets, having handoffs to get work done, and different handoffs between teams produce delays every step of the way. The parallel solution that DevOps provides is to break down these siloed walls and align the skills in a cross-functional team, all pulling in the same direction around a specific business capability. This is your DevOps team or your business capability team. Now, the misconception with DevOps is generic developers responsible for absolutely everything. The reality of DevOps is a number of cross-functional business capability teams, each aligned around a common objective, responsible for the entire app lifecycle of what they produce. So how does Cloud Foundry help with DevOps? Well, it's really similar to Agile. Cloud Foundry is a DevOps enabler. It's great that you now have your business capability teams focused on products versus silos of speciality focused on projects, but these require a platform in order to deliver software with velocity, and that's what Cloud Foundry provides you. So platform operations, this is really an extension of the DevOps argument. It may be stating the obvious, but when it comes to installing and running Cloud Foundry itself, it doesn't work very well if you run this project with these silos of speciality or with the burdensome communication flows. If you adopt a centralized deployment of Cloud Foundry, you need to establish a business capability team, often known as a platform operations team, responsible for building and running Cloud Foundry itself, this cross-functional team focused on the platform. You also need a platform champion to passionately evangelize the benefits of using a platform across the other business capability teams. Moving on to another hot topic, microservices. The term microservices architecture has sprung up over the last few years. It describes a single application comprised as a suite of smaller services. These smaller services typically focus around a single. They're typically built in isolation and independently deployable. The different services can be implemented using different languages, different back-end storage technologies, and so they have the freedom to evolve as required. So what are the microservices misconceptions? There are inherent challenges with any effort at componentization, but assuming you can get the architectural design right, like all software, microservices still require platform support for things like environment provisioning, resiliency, data management. But more critically, when you're dealing with complex distributed challenges at the application level, platform level support isn't enough. New challenges start to arise to include things like configuration management, and service registry and discovery. So how does Cloud Foundry help here? Well, Cloud Foundry and microservices really complement each other. They've been called a symbiotic match. Out of the box, Cloud Foundry provides all the deployment and platform level support for running your services. Concerns such as user management, log aggregation, security, etc. However, Cloud Foundry does look at your applications that you deploy as individual components. And if you take all those microservices that compose your app-level distributed system, you still need a framework that deals with those distributed system concerns at the application level. And that's where technologies like Spring Cloud really help. Spring Cloud uses boilerplate patterns like circuit breakers, service discovery, config management to take the individual services and compose them into a single system. So finally, Cloud Native. Cloud Native brings us to the end of our journey of delivering with velocity. And we've covered a lot with containers and Agile and DevOps and so on. I would argue that you can do all those other things, but that doesn't mean you're inherently Cloud Native. However, I believe you can only really be Cloud Native if you do those other things. And that's when understanding of the value of those concerns is so important. So I've not found many misconceptions with the term Cloud Native, just more of a lack of awareness of what it is. I found one definition on Wikipedia that's limited and specific to apps. So I've defined it as follows. Cloud Native is a term describing software designed to run and scale both reliably and predictably on top of potentially unreliable cloud-based infrastructure. That means that cloud-native applications will have a characteristic of being purposefully designed to be infrastructure unaware, meaning they're decoupled from that infrastructure. So what are the key takeaways? We've discussed the key issue, which is one of delivering software with velocity. And the buzzwords, these wider IT concerns that can get in the way if they're not properly understood. So the final takeaway is what I call the Cloud Foundry hamburger. Cloud Foundry is an amazing enabler for companies looking to repeatedly deliver software with velocity. However, no matter how good the technology is, technology alone is never enough. companies need to fundamentally change the way they deliver software through things like agile feedback loops, DevOps business capability teams, and cloud-native microservices. The good news is that Cloud Foundry as a platform is a cross-cutting concern across both the lines of business and these broader IT concerns drive their organizational change. So with that said, once you've installed Cloud Foundry and once you've transformed your organization to adopt all these other concerns, you can just sit back, keep calm, and see us push. So thank you very much for joining, and I'd like to open this up to Q&A.
Great. Hey, Duncan, thank you so much for the presentation. Looks like we had a few folks in attendance today, but no questions at the moment. Is there anything maybe that you heard in terms of thoughts when you presented this at CF Summit that you want to share with us, or other questions or reactions that you've heard from folks that have seen this content?
Yeah, sure. I mean, one of the things that I get asked a lot is, what's the single most important piece of technology companies are often trying to adopt? I mean, is it challenges getting to grips with microservices? Is it challenges with adopting containers? Or, setting up a CI pipeline? And typically, when we work with companies, we find that when you focus on an individual piece of technology, and that's your primary focus, you're not really getting the benefits or the maximum benefits from that technology, because they're designed to work with other things and they're designed to work with other concepts. And when you start to put all that together with a platform like Cloud Foundry, you can really start to draw the benefits of containers for your continuous deployment pipeline or containers for your microservices. So having a platform, as we touched on towards the end of that presentation, really starts to pull in all these different industry trends together.
Cool. Let's see. Huntsy from Cisco asks, do you allow the migration of legacy Java applications onto Pivotal Cloud Foundry?
Yeah, that's a question that comes up a lot, and it's a really pertinent question. So the answer is yes, but it depends on how that legacy application is constructed. So typically, the way something like Cloud Foundry works, because it deals with containers, it deals with ephemeral infrastructure, it makes certain expectations about how your application is developed. And we touched on this at the platform level with the way the platform is opinionated. And this is where concepts like 12-factor apps are often discussed. There's certain things in your application that needs to be architected in a specific way, not to write data to the local file system and things like that. So it absolutely can run legacy workloads, legacy applications, but you need to look at those applications and understand how they're architected to make sure they're going to work in Cloud Foundry.
So Duncan, that's where a lot of the 12-factor stuff comes in, and speaking as a former sort of BEA, WebLogic, and briefly Oracle employee, I mean, I think to just dive into that a little bit more deeply, since we have some extra time, and I think we're hoping that this is kind of a conversational format. So you folks on the line listening, we had a short bunch of slides today, but you've got a real expert in Duncan Winn here on the line. So bring us your questions, and let's make this conversational as possible.
Yeah. So to give you some more context on that, there's like a WebLogic build pack, and there's a Tommy E build pack, and there are build packs available to run some more of these legacy applications. But if you're starting to use things like WebSphere native APIs, or if you're starting to use transactions, it's those type of things that you may have to start to pull out and refactor.
Yep. Another way to think of it is, a simple sort of way to think of it is the farther you go beyond the servlet API, the more you're going to need to really look at what you've done in terms of, like Duncan just said, API usage, local file system usage, transactions, and look for violations of 12-factor. And not all Java EE apps are designed that way. It just depends. Often people that have just kind of used the servlets and web apps on Java app servers. A lot of times those aren't anywhere near as difficult to port, because they're not using these things that sort of expect a local file system or, other cloud anti-patterns, which are very deeply explained in sort of the 12-factor approaches.
Yeah.
Next question is from, so thank you, Hansi, for that. Next question is from John Royal at IDS, and he said, how does AWS compare to Cloud Foundry, and would it be considered as cloud native?
So that's a good question. So AWS is complex because many people see AWS as an IaaS, and Cloud Foundry runs on top of AWS. And so in that sense, like vSphere and like Google Compute Engine, it's an IaaS that underpins Cloud Foundry. But the thing with AWS is they offer such a rich set of services that those services start to bleed into that platform layer. So, I mean, it's not an absolute sort of platform like Cloud Foundry, but it does offer additional services, especially around backing services like, database services and all sorts. So whether you'd consider it cloud native, I mean, it is cloud-based infrastructure as well. So the term cloud native is ambiguous. It means different things to different people. But yeah, I mean, AWS is cloud-based infrastructure and a suite of cloud-based services.
And I think a lot of times what we at Pivotal mean by cloud native, right, Duncan, is that, it's the confluence of, this sort of multi-cloud IaaS, a microservice approach, continuous delivery, and containerized, containerized processes and sort of, the sum of those things is what we typically characterize as what is cloud native. And so I think it just, my own opinion is I think it just kind of depends on how you use AWS. I think one of the other sort of reasons why it's different is that, Pivotal is sort of, we're focused on providing a kind of structured platform for all the various, and sort of end-to-end from the app stack all the way down to the IaaS. And so, excuse me.
So, I mean, the way I see it, AWS is like this huge toolbox, and you get a load of independent tools, and you can do a lot with those tools. But, I mean, essentially, just on the cloud native, when we talk about cloud native, we're typically referring to cloud native applications, so applications which are designed to really excel and thrive in cloud native infrastructure. And AWS is your cloud native infrastructure. But also the thing I like about Cloud Foundry, as Peter touched on, is that because it's an opinionated platform and you're not locked into the specific infrastructure, it provides this abstraction layer, effectively like this operating system above the infrastructure. So your applications that run on Cloud Foundry will run on Cloud Foundry, whether it's on AWS or on vSphere. And it means that you're decoupled from the underlying infrastructure. If you go natively into AWS, you end up putting a huge lot of resources into leveraging those AWS-specific APIs. It means you're locked into that infrastructure at that point, so it's harder to rip out and move your environment onto something else.
Excellent. Thanks, Duncan. Next question is from Eric Swanson, and his question, it got truncated a little bit, but I think I'm hoping he I'm hoping he's still on and will expand on it, but I asked him to do that. I think what he's getting at is he asks, hey, microservices is sort of touted to enable organizations to build with the right tech, like including Polyglot. However, companies struggle to standardize templates and tooling to hone skills and knowledge. How would you enable teams without sacrificing, and then this question gets truncated, but I think I kind of get the direction he's going. It's sort of this sort of polyglot versus, using a consistent single language approach or something like that. Could you talk about that a little bit?
Yeah, sure. I mean, the key thing here is you have choice, right? So, I mean, you can choose to have a polyglot environment where every single individual team is free to develop the service using the language they're after and the data store they, want to use, the data store they feel is most appropriate. And so using that microservice architecture, providing the boundaries between the individual services are well-defined and explicit, you're free to choose. Now, if an organization doesn't want to have that different mix of technologies and languages, you can absolutely standardize and say, effectively, we're a Java shop, our developers use Java, so please write your services in Java, use MySQL or use MongoDB or whatever else you want to back it with, or standardize on this backing service. But the key thing is you have choice. For me, microservices is not just around being polyglot. It's around decomposing your big monolithic application into a suite of smaller services, so individual teams have jurisdiction on how that service should be written. So they can scale the service independently, they can move quickly, developers can get started, more productively by working in a smaller code base. It gives you a load of other advantages. It's not just about being polyglot, either with the language or the backing service.
Great, thank you, Duncan. Oh, and he responded and said we did a good job of interpolating his truncated question. Excellent. So next question is from Aaron. I hope I'm saying his name correctly. Forgive me if I'm not, Aaron. What examples of Cloud Foundry exist where Cloudera has been used as the Hadoop stack? Could you describe? We are struggling with this use case.
Yeah, so Cloud Foundry is a platform for running your applications. And as the person who raised the question, I'm sure is well aware, so Cloudera and Hadoop are really for your heavy sort of data-orientated workloads, doing your computational analysis on big data, all of that sort of stuff. So the beauty of Cloud Foundry is there's a number of extension points. So you can push your applications to Cloud Foundry and you can bind those applications to a backing service. So if you have a large Hadoop cluster, you can expose that Hadoop cluster to Cloud Foundry, and then you can allow the applications on Cloud Foundry to leverage the cluster and leverage the data in the cluster and run queries against the cluster. So typically, and again, Pivotal has a whole suite of technologies and products around this space, but typically the way we'd integrate the two is to expose Hadoop and additional services to Cloud Foundry for the applications on Cloud Foundry to then leverage that data suite.
Excellent, thank you. Let's see, Eric Swanson again is curious. They're utilizing IBM Bluemix, which is a derivative of Cloud Foundry, a distribution, IBM's commercial distribution on top of an open source Cloud Foundry. And they realized that the endpoints are public and cannot be secured behind traditional networking security. Is this a Bluemix specific issue or a Cloud Foundry issue? They need to implement basic auth, for example, or OAuth tokens for every single service.
Yeah, I've not worked with Bluemix, so that sounds very much like a Bluemix issue. There's absolutely ways you can lock down Cloud Foundry and make it secure. So yeah, I think that's just the way they've configured their Bluemix environment.
Got it. Okay. Makes sense. Thank you. Scott Campbell asks, so Duncan, you touched on containers, which are getting a lot of attention these days, especially Docker. Can you elaborate on Docker versus Diego and when one may be more appropriate than the other?
Yeah, sure. So again, I think the challenge with just the word Docker is means many things. When most people talk about Docker, they're generally referring to Docker images. Docker is also a company, and as a company, it has a number of different products. So in terms of the way we interface with Docker, and again, we touched on this briefly during the presentation, Docker images are in really wide use. They're very popular. And you can push Docker images to Cloud Foundry, and you can run Docker images in Cloud Foundry. The way Docker Engine, I believe, works is it uses this backend component to run applications called runC. And we, Cloud Foundry, use the same backend runtime as well. So we use runC as well. So your Docker images also effectively run in the same backend with Cloud Foundry. What's important is the abstraction above just using Docker images. So using an orchestrator to manage the container lifecycle is where Diego comes in. So Diego allows you to push Docker images or applications to Cloud Foundry. And it takes the responsibility of instantiating and running those applications in new containers or running those Docker images on a cell. And it monitors the health of those containers. And if a container dies, it will bring it back again. It reconciles desired state and actual state. And it looks at the health of the whole system and manages those container life cycles.
Great. Okay, thank you again. Let's see. So, there we go. Question from Jack Balthasar, and he asks, Duncan, could you talk about cloud journey? We're hearing that more often. And curious as to how well defined or typical you see cloud journey, whether you see various scenarios that exist, not along any continuum per se. I'm not entirely sure what he's getting at, to be honest. So
yeah,
Jack,
I mean, from what I've seen, just being in the industry, especially starting with VMware and now working for Pivotal, is generally companies have moved away from like physical service in the data center to adopting cloud, and that is definitely a process. And typically for many companies, that starts with the adoption of virtualization and using virtualized infrastructure instead of just having everything locked down on physical servers. And then from there, once you've moved into virtualization, you then have the challenge of how do you cope with this VM sprawl throughout your organization? How do you get a handle on that? And that actually is still something many companies are trying to deal with. How do you deal with 10,000 VMs within your organization? Because at that point, you know, you're kidding yourself if you think you've got a good grasp on the nature of what's in every single VM. But this is where something like Cloud Foundry really comes into its own, because it leapfrogs you forward to managing those VMs on your behalf. So you don't really have to care about the VMs that Cloud Foundry manages. You know it spins up VMs, you know it runs applications on cells, and then there's system components running on other VMs. But by having a platform, an abstraction level above your IS layer, again, it decouples the development team from having to understand what's in a VM and having to build those VMs. So it leapfrogs you forward to actually enabling your developers to just push their code, bind those applications to services, and work at a higher level of abstraction. I'm not sure if that answers the question, but that's how I'd sort of anticipate what you're asking.
Yeah, no, he clarified in a subsequent comment saying that, you know, VMware and then like an arrow, you know, cloud native, yes. So it seems like we're answering on the right axis, and he just said yes again. So, yep. Yeah,
and so just to add to that, with that journey, once you start pushing applications to Cloud Foundry, that's all very well and good if your applications are standalone, but microservices architecture has really come into its own over the last couple of years. And as we touched on during the presentation, that is really where most companies are at with their progression and adoption of being cloud or journeying into the cloud. Because you need this framework on top of a platform like Cloud Foundry to take your individual small services and turn it into a more holistic application. So technologies like Spring Cloud and other technologies like that, this microservice framework really helps you leverage microservices on top of a platform like Cloud Foundry.
Excellent. All right. Well, it would appear we have temporarily exhausted the question queue. Thank you, everyone, so much for the interactivity and all your questions. If there's any last thoughts, please don't hesitate. You know, Duncan's a super busy guy out in the field, so he's a hard guy to get time with. So if you have any other questions, this is the time. One thought that I just wanted to offer was that, you know, we are recording this so that slides and replay will be made available on the Pivotal site. So if you found this useful and you want to share this with your colleagues later, you're more than welcome to do that. And I think it's a great primer on sort of how things are, you know, what this space is about, and getting some top level sort of guidance on how to consider all this stuff. Duncan, I heard it went very well at Cloud Foundry Summit for you with this, and yeah, I think it's a great primer for people. So hopefully, Duncan will be able to get you back again on the webinar program and talk to some more topics. I understand that you have a book available. Could you talk a little bit about that?
Yeah, sure. So, I mean, the book is primarily why I did the presentation. So as part of writing that book, you start to explore all these different technology trends, and you have to sort of really unpack what do they mean in the space of delivering applications with velocity, and how do they really help. So the high-level book is available. It's out now. You can just download it for free. And it starts to unpack what we've discussed during this presentation in more depth.
Excellent. I'm actually looking for the link right now to paste into the chat window. So just bear with me for a second, folks. Let's see.
Yeah, if you Google Cloud Foundry, the cloud native platform, and my name, it should just come up.
Oh, excellent. Okay, well that might be just easy for people to do in that case. So, yeah, and if this particular topic that you joined on today is you find helpful, the book kind of expands on it. Duncan, what is it again? I think it's like 50 pages or 100 pages.
Cloud Foundry, the cloud native platform. It's like 50 pages. It's a really quick
50
read.
pages, yeah. Yeah, so it's a quick read, something you can read on a flight or slide across the table to one of your colleagues, good sort of directional, piece and give you the landscape. So that book is available for free on the Pivotal website. And like you said, just do Google search for Duncan's name and Cloud Foundry, and you should come up with that or go take a look for it on the Pivotal site. I think that's it. It doesn't appear that we have any more questions at this time. So, oh wait, no, sorry. Apparently it's in the resource list. So you can click on the, if you look in your On24 user interface, down towards the bottom, there's a link to it there in the resources section. This is funny. Eric Swanson asks Duncan, he says, if I build a cloud app while I'm connected on a plane, have I achieved nirvana? Nice one. Good one. Actually, I think you probably have, because, I mean, that means you've actually managed to keep a persistent connection over go-go Wi-Fi for more than 5 seconds. I mean, that is actually quite a feat. That's definitely nirvana. Well, listen, thank you, everyone. Duncan, thank you so much for joining us and taking some time, some of your valuable time to educate us. So,
yeah, my pleasure.
Hope to have you back, and yeah, please check out Duncan's book if you're hungry for more details. Thank you, everyone, and I hope to see you on another Pivotal webinar again very soon.
Thank you. Bye for now.